Okay, let's start. So already we have discussed one theorem from the circle. Let's start with the next theorem and then we will be moving to the exercise. We'll be doing few questions from exercise. So let's see one by one. So our next theorem is suppose the lengths, like the lengths of tangents the length of tangents drawn from an external point will just a second now. Just give me a second. Can you see the screen?
Yes, ma'am.
From an external point to a circle are equal. Okay, so it says the length of tangent drawn from an external point to a circle are equal. So if we are drawing a tangent, suppose we are having a circle like this, an external point. So the external point can be anything. Suppose we are drawing a tangent like this. Here we are having the center of the circle as O. All right. So let O be the center of the circle. Then the length of tangent drawn from external point. This tangent length, let's say E. Okay. This theorem already we have covered, right? From an external point, like let's say from point P, if we are drawing a tangent over here, just a second, what is happening? If we are drawing a tangent like this and the tangent are of same length, right? This theorem we have already covered in the previous class, right? Can you recall this theorem, both of you? I'm not talking about this AB. I'm talking about P from a external point P. If we are drawing PA and if we are drawing PB, both PA will be equals to PB, right?
Yes, ma'am.
That one we have covered in the previous class. Today we will be covering the next one, which says prove that what is happening in this? prove that in two concentric circle, the chords of larger circle which touches the smaller circle is bisected at the point of contact. So here the theorem says, prove that two concentric circle means two circle having the same center. Okay, so if I am drawing a smaller circle, then I'll be drawing, let's draw. If the center of this circle is O, then I'll have another circle whose center is same. Okay, that's the meaning of co-incentric, like same center. Both the circles are having same center. We have to show that two concentric circle, the chord of larger circle which touches the smaller circle is bisected at a point of contact. So the chord of the larger circle, we will be drawing chord in such a way of the large circle. Let's say we will be drawing the chord like this. Here, this is the point of contact. We can say P is the point of contact which touches the smaller circle bisected at the point of. If this is chord is AB, then we have to show that AP is equals to BP. That's the meaning of getting bisected. Okay, here the chord AB is getting bisected by the, when we are just a second, no, I don't know why every here we have to show that AP is equals to BP. Can you see the screen?
No, ma'am.
No? Okay, I'm not sharing it. Can you see the screen now?
Yes, ma'am.
Here, can we say that OP is perpendicular? Like here, so it's 90 degree. Can we say?
Ma'am, can you repeat? Your voice was lagging.
My voice is lagging. Is
It
it
was
clear now?
lagging. Yes, ma'am. Can you repeat?
Yeah. So Can we say OP will be perpendicular to AB?
Yes, ma'am.
And we know whenever we drop a perpendicular line on any line segment, that perpendicular line divide the line segment in two equal parts, right?
Yes, ma'am.
So from there we can say, since it's a perpendicular, it is dividing AB in two equal parts, and hence AP is equals to BP. All right?
Okay, ma'am.
Yeah. Let's do the next theorem. So here the next theorem says two tangents. Let me draw the figure only rather than writing the whole thing. So next theorem is there, which says two tangents T a circle, and here we are having two tangents TP and TQ. So are drawn to a circle with a center O. Here the center of the circle is O. From external point P, as we can see, from external point T, we have dropped two tangents, that is TP and TQ. Prove that angle PTQ is equals to 2 times angle. Okay, this is what we have to prove here. So if we will focus on this, let's join them. Like this. And okay, this is the angle OPQ. Now, if we will do like this, can we say we already know that TP will be equals to TQ from the first theorem? Can we say?
Yes.
Yes or no? We can
Yes.
say that TP will be equals to TQ because both are just tangent line drawn from a common point, right?
Yes.
So this 2 TP will be equals to TQ. Then can we say it's an isosceles triangle? Triangle TPQ, isosceles triangle, where this angle, the opposite angle must be same. That means this angle will be equals to this angle. Is there confusion regarding this? Are you getting it?
Ma'am, your voice is lagging. Can you repeat?
Yes, Jaslyn, are you saying something? Is it clear till here?
Ma'am, your voice is lagging.
Uh, I'm not getting. What are you saying?
Ma'am, your voice is lagging.
Is it possible to write it in the chat box? Like, is it clear or not? Are you writing? This is what we have to prove here. This is what we have to prove here. And we are starting with the triangle TPQ. We can see it's an isosceles triangle. Hence, I am saying that opposite angle will also be same, right? Now we can say that angle TPQ must be equals to angle TQP, right? Are you getting it? Am I audible to you? I'm not audible. Is it still lagging?
Ma'am, now it's fine.
Not now. Is it clear now?
Yes, ma'am.
Okay, let's continue. So I was saying that if we will focus on triangle TPQ, can we say it's an isosceles triangle where TP is equals to TQ? And since it's an isosceles triangle, opposite angle must be same, right? Can we say it? Now here, if we will take all the angle in triangle TPQ, so we can say angle PTQ plus angle TPQ plus angle TQP. All together it's 180 degree by angle some property of a triangle, right?
Yes, ma'am.
Yeah. Here these two angles are already same. These two angle TPQ and TQP are already same. And if I am saying this angle T, so let's say we are taking it as a theta. So plus angle TPQ plus again I am going to write TQP as angle TPQ only. I don't know what happened suddenly. Like, let me explain it on whiteboard only. So this is the figure we were having. If this is we have taken as a theta, and we are saying that in triangle TPQ, angle angle PTQ plus angle TQP plus angle QPT, that is 180 degree by angle sum property. Now here two angles are already same and one of the angle is theta. So I am going to write angle TPQ two times angle TPQ is equals to 180 minus theta, right? Here we can say angle TPQ is equals to 180 minus theta over 2. Can we say like that? Let me off the video. I believe it will get normal. Can you see it now?
Yes, ma'am.
Yeah. Due to video, it is taking more, like it is lagging a lot. Now we can say that angle TPQ and or this angle P or this angle Q both are same. So angle PQT is equals to 90 minus theta by 2. Can we say both are exactly same? Can we say like that?
Yes, ma'am.
Yeah. Here we know angle OPT is equals to 90 degree. From center O, if you will draw a line and will connect it at tangent, it will be of 90 degrees, right? So this total will be of 90 degree. All right. So here we can say angle OPQ is equals to the total angle OPT minus angle TPQ. Is it clear to both of you that we can write this smaller angle as total angle minus the other angle, that is TPQ or QPT? Can we say both? Are you getting it?
Yes, ma'am.
Yeah. So here we will say, let's substitute the value from equation 1. Here we can say that OPT is 90 degree, already we know from equation 2, and from equation 1 it will be minus 90 minus theta over 2. So here we got directly only theta over 2, and theta is what? Theta is angle PTQ, which we have taken by ourselves. And what we had to prove over here, we had to prove that angle PTQ is equals to 2 times angle OPQ. And you can see here we got that 90 minus 90 will cancel out each other. Minus theta by 2 will be plus theta by 2 when we will take it out, and it will be angle PTQ is equals to 2 times angle OPQ. Can you see that?
Yes, ma'am.
Is it clear to both of you?
Yes, ma'am.
Yeah. First we have taken the isosceles triangle. Then we have used that condition to prove the given theorem. Let's do a few questions from exercise. So from a point theta, the length of tangent, let me draw the figure directly. So if we are having a circle, and if from a point O, if we are drawing, there is a tangent over here, that is PQ. And if we are dropping a perpendicular like this on the tangent, here length PQ is already given as 24, length OQ is already given as 25. Can we find the length OP, the radius of this circle? How to find OP? Any idea? How to
Can
find OP over here?
Pythagoras theorem?
Yeah, we can apply Pythagoras theorem, right?
Yes, ma'am.
Yeah. So by applying Pythagoras theorem, easily we will be able to find OP, right? Let's do the next one. The second question, where the figure is given like this. And there is a point T over here. we are dropping a tangent like this and a tangent like this. Here is the center O. This and this. This total angle is given as 110 degree. And we have to find here angle PTQ. We have to find this angle over here. Okay. Hi Mariam, are you from class 10? Okay, she is waiting in the waiting room. Are you from class 10? Yes, Mariam. Can you please unmute yourself? Can you see me? Okay. Okay, let's continue the discussion. So here we have to find angle PTQ, okay, in the given figure. Here we are having a center O. All right. Can you see the screen? Am I audible to both of you?
Yes, ma'am.
Yes,
So
ma'am.
can we say if this is P, this is Q, then PT will be equals to TQ?
Yes, ma'am.
Yeah, because from an external point, we are dropping the tangent. So the length of the tangent will be equals to each other. So obviously PT will be equals to PQ, right?
Yes, ma'am.
All right. Now, in if we will focus on this one, can we say a line drawn through the radius, like radius OP on the tangent PT, it will be perpendicular to PT? Can we say both of them will be perpendicular? So can we say over here that angle TPO just a second, angle TPO and angle TQO both will be 90 degree, right?
Yes, ma'am.
All right. Now, if we will focus on quadrilateral OPQT, can you see the quadrilateral OPQT? It's like
Yes,
this one,
ma'am.
quadrilateral. Okay, OPQT. So, angle sum property of quadrilateral, what does it say? The sum of interior angle, sum of all the interior angle of a quadrilateral will be of what? Is it 180 degree or is 360 degree?
360.
It will be 360 degree, right? So sum of all the interior angle, that is this angle, this angle, this angle, and this angle, it will be of 360 degree. So we know already three of the angle, like one is 110, another is 90, another one is also 90. We have to find angle T. Okay. So with the help of angle sum property of a quadrilateral, we will be able to find the unknown one, right? Are you getting it? So we can say 110 plus 90 plus 90 plus angle PTQ, that will be equals to 360 degree. And from here we will get the value of angle PTQ, right?
Yes, ma'am.
Let's do the next one. Now the next one, question number 3 says, if a tangent PB and PQ, PB and PA from a point P to a circle, let me draw the figure. So if we are having a circle, the tangent PB and PA from a point P to a circle with center O are inclined to each other at an angle of 80 degree. Okay. Let me give it a name. PB and PA. Both are inclined with each other at total 80 degree. What we have to find over here, let me read. We have to find angle POA. So this angle, if this is the center, we have to find this angle. All right. So again, we can join it. The radius we can join and we can say it's of 190 degree, right? This one, here it's 90 degree. This one, here it's 90 degree. Is it like, do you agree with that? Right? Now, if
Yes,
we will
ma'am.
take this triangle OBP and OAP, let's take both the triangle. Okay, let me off the video so that it will get smooth. So I'm saying I want to take triangle OBP and triangle OAP. Okay, we have to show that these two triangles are congruent with each other. All right, by any of the congruency rule. It can be side, side, side. It can be side angle, side. It can be angle, side, angle. So by using any of the congruency rule, we can prove that these two triangles are congruent with each other. Let's see which congruency rule is applicable over here. So in triangle OBP, at first we can see this B is 90, A is 90. Let's write it. Angle OBP is equals to angle OAP, right? Now we can also say that there is a common side, that is OP, that is in both the triangles. So OP is equals to OP, right? This side is common in both the triangle. We have to write it over here that this is the common side. All right. Are you there?
Yes, ma'am.
Okay. Now the next one is, we know PA will be equals to PB, because from a common point, if we will drop a tangent, that tangent will be equals to each other. So these three condition, what is the condition? We got one of the sides same, We got another angle same, and then we got here also side same. So we can say these two triangles, that is side let me check what. Okay, rather than this side we can say OB is equals to OB. Then it will be this radius and that radius will be equal. Then only we can say this OB, just OB and OA as a same, because both are radius only. Then we can say it's following the congruency criteria, that is side angle side. Can you see it? Do you know the concept of congruency?
Yes, ma'am.
Yeah. So here now we can say that triangle OAP and triangle OBP both are congruent with each other by which rule? By side angle side congruency rule. Okay.
Okay, ma'am.
Here,
Yes,
once
ma'am.
we have shown it's a congruent triangle, now their corresponding side will be equals to each other. So what are the corresponding side? Corresponding angle will also be equals to each other. So we can say this angle will be equals to this angle. Okay.
Okay, ma'am.
So if total is 80, if total is 80, then we can say this is 40 and this is 40, right? Now what we had to find over here, we have to find angle POA. Here if we will focus on triangle OPA, and if we will take the angle sum property of a triangle, can we say one is 90, another is 40, then this angle easily we will get this angle, right? Can we say we will easily get angle POA by taking the triangle OPA or POA?
Yes, ma'am.
Yes. So we are done with finding the angle O. What we did, first we have proved that these two triangles are congruent by applying the concept of congruency. Okay. Once we have proved these two triangles are congruent, then this OP became the bisector. Like bisector means just that angle, this angle became same. So total is 80. So that will be 40. This will be 40. Once we got 40 over here, now we can completely focus on triangle OPA and we can find the unknown angle O. Okay. Now the next theorem is, or the next question is, prove that tangent drawn at the end of a diameter of a circle are parallel. So if we are having a circle like this, and if we are drawing a tangent over here and a tangent over here, and if we are having diameter like this, so the theorem says prove that tangent drawn at the end of the diameter. See, we are having a diameter AB over here. And at the end of the diameter only, I have drawn the tangent. That is tangent PQ and tangent RS. we have to show that both are parallel with each other. That is PQ is parallel to RS. That's what we have to show here. How we will show that PQ will be parallel to RS? First, we can say that here we are having a 90 degree. Here it's 90 degree because from the radius, if we are dropping a line on the tangent, that will be perpendicular, right?
Okay,
Here
ma'am.
also we can say it's a 90 degree. All right. Here also it's a 90 degree and here also it's a 90 degree, both sides.
Okay, ma'am.
Yeah. Once we will say both are 90 degree, now we know parallel line condition is this is 90, this is 90, this is 90, and this is 90. Now the condition of parallel line is if we are having two line PQ and RS in such a way that there is a transversal AB, if transversal is AB, and if this angle is equals to this angle, then both are making pair of alternate interior angle, right? And since these two circles are same, we can say line PQ must be parallel to line RS, right? Because alternate interior angle are same over here. We can also use co-interior angle. We can say 90 degree plus 90 degree is 180 degree, which happens only in between two parallel lines, right? Are you getting
Okay,
it?
ma'am. Yes, ma'am.
Yeah. So hence both the line must be parallel with each other. Now the next theorem or the next question says, prove that the perpendicular at the point of contact. Let me draw a circle. Here we are having a point of contact. Yesterday only, like in the previous class only, we discussed about point of contact. So if the point of contact is P, okay, prove that the perpendicular at the point of contact. So if we will drop a perpendicular to the tangent to a circle, passes through the circle. Okay, passes through the center of the circle. We have to show that when we are dropping a perpendicular, that perpendicular must be passing through the center of the circle, not from anywhere else. Okay, if you will drop a perpendicular on the tangent, that perpendicular will meet the center of the circle only, not in any point on the circle, on in the interior part of the circle or the exterior part of the circle. It will not be a random point. You will get perpendicular only and only when you are dropping it from the center. Okay, that's what we have to prove here. So we have to show that OP is perpendicular to AB. Here this is A and this is B. So here we can write, we know that tangent of a circle tangent of the circle is perpendicular to the radius, that we know already from one of the theorem. We can say OP is perpendicular to AB. Now let's say there is a point X. Okay, and here if we will drop a line from X, let's say there is a point X such that XP XP is perpendicular to AB. Now, is it possible that a straight line we are having and the two perpendicular, like this is a perpendicular, that is also a perpendicular, this is also a perpendicular? It can't happen, right? Only one line can be the perpendicular. Here we are saying OP is a perpendicular by one of the theorem, but we are taking by ourselves that XP is also the perpendicular, which is not possible at all. Okay, on one straight line from a point, you can drop only one perpendicular. Okay, so here we can say which is not possible if angle XP B is equals to 90 degree, you are saying, and you are also saying that angle OPB is equals to 90 degree, then either both of the O and X are the same point, or this is not possible. If both are different point, then this is not possible. Okay, so here we can say from 1 and 2, we can say both are exactly the same point. O and X has to be same point, or if O and X are different point, then this is not possible. Okay, hence there can be only one point which is center. Through that point, we can drop a perpendicular on the tangent. Okay, is it clear to both of you?
Yes, ma'am.
Yes.
Let's do the next one. So the length of tangent from a point A at a distance 5 centimeter. So we are having a circle. Now the length of tangent at a point from a point A. So this is A, and from here we are drawing a tangent like this. Okay, at a distance 5 centimeter from the center. So the distance of this A is 5 centimeter from the center. And the length of the tangent is 4 centimeter. So this is where we are getting the tangent. AB is the tangent line. Here it is given as 4 centimeter. That is given as 5 centimeter. We have to again find OB, which can easily be found by Pythagoras theorem, right? Because this is a right angle triangle, right?
Okay, ma'am.
Yeah. So this one you will be able to do by yourself. Let's do the next one. Two concentric circle of radii 5 centimeter and 3 centimeter. Again, concentric circle means two circle which are having the same center. This is the center O for this circle, and the same center O is for the larger circle. It's just like you are stretching your compass. You just press the needle of the compass at a point O. Now you have kept it closer and you drawn one circle. Now without taking up the needle of the compass, you are drawing another circle by just stretching the arc. This is how you will get the concentric circle. Okay, so two concentric circle of radius 5 centimeter and 3 centimeter. So the bigger one is 5 centimeter radius and the smaller one is 3 centimeter. Okay, now here it says find the length of the chord of larger circle which touches the smaller circle. Length of the chord of the larger circle, a chord which we have to draw in the larger circle which will touch the smaller circle, just touch. Okay, that means that chord will be the tangent to a smaller circle, just like this one. Can you see? Blue line is a chord for the larger circle and blue line is a tangent to the smaller circle. This is how the question is given. We have to draw the figure by ourselves. All right.
Okay, ma'am.
Now here we can say this is a straight line A, P, B. This is 5, this is 3. Then easily we will be able to find the remaining. That is AP we can find. This is a right angle triangle because on the tangent, if we will just join it with the radius, it will be perpendicular. So we can focus on triangle OPQ. And with the help of Pythagoras theorem, we can find the value of AP from here. Now what we have to find, two concentric circle of radius this and this, 5 and 3. Find the length of the chord of the larger circle. We have to know, we don't have to find AP, we have to find AB. So if you will recall the first theorem, the first or second theorem, there we have discussed that this point P, the point of contact, is dividing this line in two equal parts, right? AP is equals to PB. That we have already discussed in one of the theorem. So if you have found AP from here, let's find it. Hypotenuse square, that is under root 25 minus 9. 25 minus 9 will be 16 and that will give AP as a 4. Now we are saying AP and PB are same. So AB will be AP plus PB, right? That is 4 plus 4. That means 8 centimeter, right? Are you getting it? Are you getting it?
Yes, ma'am. Can you hear me?
Yes or no?
Yes, ma'am. Can you hear me?
Yeah, I can hear. Let's do the next one. One more theorem, let's do it and then we will wrap it up. Just give me a second. Here we are having a figure like this. Okay. The question says in the given figure of quadrilateral ABCD. So A, B, C, D, it's a quadrilateral ABCD where quadrilateral ABCD is drawn to circumscribe a circle. Can you see it is circumscribe a circle? Inside the quadrilateral there is a circle, right? With center O. So here we are having a center O in such a way that A, B, B, C, C, D, D, A touch the circle. So A, B, B, C, D, C, D, D, A all are touching the circle, means all are tangent to the circle. Whenever this line touch is mentioned in the question, that means that's a tangent line. All right. And those are touching at P, Q, R, S. Let me write it. Here we are having P, here we are having Q, here we are having R, and here we are having S. All right. We have to prove that AB plus CD is equals to BC plus DA. All right. Here, from the common point D, if we will drop a tangent, this one, and will drop a tangent, this one, can we say both will be equal with each other? DR will be equals to DS. Can we say? By first theorem, from a common point, if we will drop two tangent, both the tangent will be of equal length. Now, from a point A, if we will drop a tangent that is AS and will drop a tangent that is AP, both will be equal with each other, right? So can we say AP will be equals to AS? Similarly, BP will be equals to BQ. And similarly, CR will be equals to CQ. Getting it? This is equation 1. This is equation 2. This one is 3 and this one is 4. All right. Let's add all the equation. So once we will add all the equation, it will be DR plus AP plus BP plus CR is equals to DS plus AS plus BQ